So I'm going to explain how to calculate bond energies. So let's go over some basics. Supposing we have a chemical bond. So here I've got a molecule of hydrogen, two hydrogen joined together by a chemical bond. Supposing I want to split it up into just two individual hydrogen atoms. What do I need to do in order to break that bond? I obviously need to put energy in order to break the bond. So if I put the energy in, I can cut that bond in two and I can break it up into its separate atoms. What happens if I was to do the opposite? Supposing I had hydrogen and hydrogen, two individual atoms, and I wanted to form a molecule of hydrogen. So in this case, well, we're doing the opposite, aren't we? We are forming a bond. So in this case, energy is given out when forming a bond. What about some other examples? Because it's not always going to be hydrogen. Supposing I had oxygen. So I could have an oxygen molecule and I want to split it up into two individual oxygen atoms. Well, here I'm breaking a bond. Now it's a different kind of bond. It's got two chemical bonds rather than just one, but it's the same idea. I put energy in and I break the bond. So you might remember from lessons what words we can use to describe things like this. If we put energy in to break a bond, then it is an endothermic reaction. Endo means in and thermic means heat or energy. Here we're giving out energy, so you should remember that this is an exothermic reaction. Exo means out. We get energy out of this reaction. And here again, we're putting energy in, so it becomes an endothermic reaction. So how much energy is required to do this? Well, we can look at tables of energy to figure this out. So you'll see tables like this, where you've got a list of chemical bonds and this thing called the bond dissociation energy. Dissociation basically just means break up or break. So if we are dissociating the bonds, we are breaking the bonds. And we have this unit here, kilojoules per mole. So we don't need to worry too much about this unit, but if you want to understand it, kilojoule equals 1,000 joules. The little k there means kilo, which means 1,000. And a mole is a unit which we use to measure an amount of substance. So a bit like you might say, I've got a dozen eggs, I've got 12 eggs, or I've got a couple of apples, I've got 2 apples. You can say I've got a mole of atoms, which means I've got a really large number of atoms. It's actually 6 with 23 zeros after it. So it's a massive number. So what we could do is we could then look at these tables and we can go, right, in order to break this bond, we need to put 436 joules of energy in, 436 kilojoules. In fact, it's a really big number. This one, energy is given out. So I can look at the bond HH, 436. So this one gives out 436 kilojoules if I have 1 mole. But we're not going to really talk about 1 mole again. We're just going to talk about this amount of energy. Now here we're putting energy in, so we just write this number. Here we're getting energy out, so what we say to show that we're getting it out, we write minus. I know that might seem like maybe we're losing energy, but that's just a convention. If it's a minus sign, it means we get energy out. If it's a positive sign, we put energy in. And here we can look at the table. We've got 497, so here we're going to put 497 kilojoules of energy in to break this bond. Now, those are really easy examples. It's not always going to be this easy. Supposing we have a chemical reaction like this. Hydrogen plus chlorine goes to 2 hydrogen chloride. And of course, this 2 actually just means I've got 2 individual molecules like this. So we just literally would consider a second molecule. How am I going to work this out? Well, what I need to do is I obviously need a table for these ones. So I know what the values are. So hydrogen is obviously here, that's 436. And chlorine, I've written down, and it's 243. And then HCl is another type of bond. So this one is 432. So how can I work out the energy difference? Well, what I need to do is I just need to identify all the bonds and start listing the energy. So we've got HH, HH. This is 436. Cl, Cl. This one is this one. This is 243. And then that's going to form 2 lots of HCl. So HCl is 432, and I've got 2 of them. So I've got 200, so 2 times 432. So now I can add all of this up together. So if I add it all up, I get 436 plus 243 is 679. And that is going to go to 2 times 432, which is 864. So now what is the difference between these? I'm always going to start with what I started with, and I'm going to take away what I end with. And this is really important. You'll see why in a minute. So this minus this, 679 minus 864, this gives me a minus 185, and it would be kilojoules. So what does that mean? Well, it means it's a minus sign, which means it's an exothermic reaction. So it means I get 185 kilojoules out of the reaction, and the surroundings will heat up. So let's look at a few more examples. So let's look at the first one here. Pause the video now and try this question. Okay, let's start listing the energy. So I'm going to start, it doesn't matter where you start, I'm going to start with this one. So I've got 436 kilojoules. Bromine, I've got 193. And then here I've got HBr, which is 366, but I've got a 2, so I'm going to do 2 times that. So let's now work out what I start with and what I end with. So 2 times 366 is 732, and that is going to go to 436 plus 193, which is 629. So now what is the difference? It's what I start with minus what I end with. So 732 minus 629 is 103 kilojoules. So that is how much energy there is different between the two of them. And it's a positive, so this means it's an endothermic reaction. So I have to put energy in to make this reaction happen. Okay, let's look at a more complicated example now. So pause the video now and try this question. So it looks complicated, but it's no harder than the other ones. We just need to be logical. So let's start on the left-hand side. So I'm going to start with my CC. So I need to look in the table. Now I've got 2 CC bonds here. Now I look, there's 2 lines between it. Here there's 1 line, here there's 2 lines. So I need to pick this bond here so it matches. and this is going to be 614. What else? Well, I've got CH. So CH is 413. But how many do I have? I've actually got 2, 3, 4 CHs. So 4 times 413. And then I'm going to add on my bromine, which is BrBr, plus 193. And that is going to go to this side. So let's do the same. I've got CC, which is 348. I don't know why I drew that out. 348. I've got my CH. I've got 1, 2, 3, 4. So 4 times 413. And then I've got CBr. So 1, 2. CBr is 276. So now I need to add up both of these sides. So 614 plus 4 times 413 plus 193. So on the left-hand side, I've got, a really big number. I made a mistake. This should be a plus sign. So I've still got a big number, 2,459. And on the right-hand side, I've got 348 plus 4 times 413 plus 2 times 276, 2,552. I need to work out my energy change. So I do what I started with minus what I end with. And that will give me minus 93 kilojoules. So that's the energy difference. And the minus sign shows that we're getting energy out. So it's an exothermic reaction. Okay, hopefully you're getting the hang of this now. I will put 2 more examples up and we'll work through them together. So pause the video now and try this question. So we've got a few things going on here. Let's start with the OO. We've got 138. And then we've got OH, OH. So we've got 2 times by 463. But hang on a second, I've got a 2 in front of this. It means I've actually got 2 of this whole molecule. So I need 2 of everything in order to make sure I've got the right amount. On the right-hand side, let's do the same thing. OH and another OH. So that's 2 times 463. And again, what do you notice? 2 molecules. So 2 lots of all of that. Plus OO. So OO is this one here. 496. So now what we need to do is use our calculator to work out the difference between the 2 of them. So 2 times 138 plus 2 times 2 times 463. So on the left-hand side, we've got 2,128. That is going to go to 2 times 2 times 463 plus 496, which is 2,348. Again, to work out our difference, what we start with minus what we finish with, 2128 minus 2348 is minus 220 kilojoules, which again means it's an exothermic reaction. Okay, definitely getting the hang of this now. Final example in this video. Pause the video now and try this question. So start over here. This has got a triple bond now. So something you haven't seen before, but it doesn't matter. It's no more complicated. It still has a value, 1077. We've got OH. which is, oh, I haven't put an OH, but never mind. You hopefully remember from the previous video, previous example, 463. And you'll notice I've got two of them. And then that is going to go to CO, which is 805, but I've got two of them. And then I've got one HH, which is 436. So again, let's use our calculator to work out the left-hand side. So we've got 2003. That's going to go to 2046. So to work out our difference, 2003 minus 2046 equals minus 43 kilojoules. So again, our final example here is also exothermic.